Hey everybody, let's give this belt friction problem a try. So the formula is pretty straightforward, but using it maybe requires some explanation. So let's think about what's happening here. So we're looking for the minimum force required to support this box. So let's think about it. If this is 50 pounds and there was no friction here or here, so if it's just smooth, you would need to hold this up with 50 pounds, right? But then if there's friction over here and over here, would you need to apply more than 50 pounds or less than 50 pounds? So it would be a range. It kind of just depends, right? You could, for example, you could hold, I'm just making up numbers. For example, let's say it's like 45 pounds, maybe, right? Like 45 pounds here, and then there's, say, like 5 pounds worth of friction helping you to hold this up. Or you could apply more than 50 pounds, let's say like 55 pounds, and then the friction would be opposing you, and then it still wouldn't move, and then you'd have to apply more and more force until you overcome this friction, the static friction, where then the belt will break free and then slide, and then it'll be kinetic friction. So there's some range over here. Okay, so we're looking for the minimum. So we want this to be less. Okay, so let me just draw on this picture. So there's 50 pounds over here. And then let's say, I'll just name this, let's call this F1 over here. And then I'll call this over here F2. And then this is the same cable, right? So these are both F2, and let's call this, say, F3. Okay, if there's friction helping you to hold up the box, which way is that? This way, right? Static friction helping you. This way, static friction helping you. So this is going to be less than 50 for sure. And then if you look right here, this is going to be less than 50. And then F1 is going to be less than F2, right? So let me say that again. F2 will be less than 50. Let's say F3. And then F1 is less than F2. Right, because of friction helping you to hold up the box. Okay, now let's think about that formula for belt friction. It looks like some tension, let's say on side A, and then tension on side B, E to the mu beta. Okay, and then this coefficient of friction is either static or kinetic. So in this example, we're just supporting the box, so that would be static friction. And then this is the angle. Okay, now let's think about this. What is this number? It's positive. It's greater than 0, right? Because this is some like 0.4 or 0.3. And this is the angle, like if, right, like for this fixed cylinder, the angle would be right here, pi over 2 radians. So that's greater than 0. So as long as this exponent right here is greater than 0, for sure this number is greater than 1. Has to be, right? Because e to the 0 is 1. So e to the anything over here that's greater than 0 is definitely more than 1. Okay, so then if this is more than 1, this is more than 1, then what does that mean about these two? That means, for sure, this is more and this is less. Has to be, right? Because this is greater than 1. So something small times something greater than 1 equals something bigger. So now that we know this, which side is F1 and F2? Which side of these is F2 and F3? Right here, we just said this is more than this. So F3 is more. So that means like this. F3 is more. F2 is less. E to the mu beta. How about over here? F2 and F1. F2 is more than F1. So it has to be like this. F2, like this, is more. Right? This is more than this. This is more than this. And there we go. What are we trying to solve for? So we're trying to solve for this. And then we don't know this number. That's unknown. And that's 50 pounds. Everything else we know. The coefficient of static friction, 0.4. The angle, let's talk about that. What's the angle? So for this, that's for this fixed cylinder. What is that angle? Right, it's like this. So from here to here, right here to here, that's 90 degrees. So that's pi over 2 radians. And then make sure you use radians for this angle. Okay, so that's 0.4, and that's pi over 2 radians. And then this one is this one. So that one, I mean, looks kind of just the same, right? It's fixed cylinder here to here. That's 90 degrees, which is pi over 2 radians. So if you want to solve for F1, just solve this for F2. So F2 is from this equation, F3 e to the minus mu beta, and then that number goes right there, and then solve for F1. F1 equals F2 e to the minus mu beta, and then this goes right there. F2 is all of this, F3 e to the minus mu beta times, which means F1 is F3, which is 50 pounds, e to the minus 2 mu, oh, this is mu s, beta, where mu s is 0.4 and beta is pi over 2 radians. Okay, so that's part A. Okay, so this is part A. Done. Part B. What force is required to move the box upward at a constant rate? Okay, so let's think about that. So there's this box moving in this direction. So which way is friction? So imagine the rope is moving this way. So if the rope is moving that way, there's got to be friction opposing the motion, like this. And since it's moving, it's kinetic friction. Kinetic friction. Okay, so that means if this is 50 pounds, what is this? More or less? Right? Imagine there's 50 pounds going this way, and then there's kinetic friction also going this way. So this has to be more than 50 pounds. Has to be, right? Because you're lifting up the 50 pounds plus overcoming the friction here and here. Okay, so that means if I just label it, I'll call this like F1, F2, F3. So for sure, F1 is greater than F2, and F2 is greater than F3. This is 50 pounds. All right, so then if we use our formula, say F1, F2, this is the one that's more, right? E to the mu k, because now that's kinetic friction, beta. It's the same pi over 2 radians, and then mu k is 0.3. And then here, F2 is greater than F3. Right, this is the one that's more, this is the one that's less. So if you want to solve for F1, F2 goes right here. So F1 is F2 e to the mu beta, and F2 is this. And then see this common, so F1 is 50 pounds e to the 2 mu k beta, where that's 0.3 and that's pi over 2 radians. Okay, so this is part B. All right, hope that's helpful. It's kind of a long explanation, but I think important, because once you get a hang of it, then any belt friction problem maybe seems as straightforward as this. Okay, so let me know if you have other questions. I'll see you in the next video.